This morning we're going to look at question number 8 from chapter 5. This is the chapter on elasticity. So question 8 tells us that the New York Times is reporting that subway ridership is falling after a fare increase. So we've got a situation there where the price is changing, that's the fare change, and then the ridership is changing, that'll be the change in the quantity demanded. They give us some specific numbers. They're going to tell us that for the first full month after a price of a token increased 25 cents to $1.50, when that took place, the rides went down by 4.3%. So a good practice when dealing with these sort of problems is just sort of look to the question setup and see what you can pull from it. What's the question telling us? So let's see here. The question setup is telling us a couple of things. First up, they're telling us that when the price changed, the ridership went down by 4.3%. In the context of an elasticity problem, all that is the percentage change in quantity demanded. So that's given to us. So let's just write that down on the board so we can look at that. Given to us is that the percentage change in quantity demanded is negative 4.3%. No calculations needed, they just told us that. Negative 4.3%. Okay. That took place when the price of these subway rides was changing. So it says it increased 25 cents to $1.50. So I would take that to mean that the first price, P1, was $1.25, and then they raised the price up by 25 cents to $1.50. Okay, so this is all the information that's given to us, and we're going to work with that. All right, part A of this problem is asking us to estimate the price elasticity of demand. Okay, we can do that. Price elasticity of demand, you'd want to remember the formula for this. It's going to be as follows. The absolute value of the percentage change in the price, the percentage change in the quantity demanded, always quantity on top, over percentage change in the price. Just like that. Okay, so we've got one of those already, that 4.3%. We can just plug in right there. And then we got to use these two data points on price to figure out the percentage change in the price. Okay, so let's do it. The percentage change for our price, we can figure that out by using the midpoint method. That's where you take the difference between the two data points and then divide it by the midpoint. So we'll take the new price minus the old. That'll give us the difference. This will be $1.50 minus $1.25. And then we're going to divide that by the midpoint, or the average of those two prices, which we get by adding them up. $1.50 plus $1.25. And then divide that result by 2. So that's divide by 2 right there. Lastly, to put it into percentage terms, you got to multiply the whole thing by 100. So there you go. That's the setup for the percentage change in the price. A pitch here, if you're at all uncomfortable on that process, this little calculation here of percentage change, you're going to want to see the previous mini lecture where we do a problem on that in a little bit more detail. But for now, we can go quickly. So the percentage change in price, just simplify a little bit, that's going to be on top in the numerator, 25 cents, divided by the average of those two, which is $1.37 and a half times 100. Put it into percentage terms. And then lastly, you just need to calculate this up to get the percentage change in price being equal to 18.18%. That's what you got to. Okay. So with this percentage change in price then, we're going to use that in combination with the negative 4.3, the percentage change in quantity, to get our big answer here for elasticity of demand. So the elasticity of demand then is going to be the absolute value of negative 34.3 over 18.18. So price elasticity of demand is going to come to 0.24. 0.24. Just like that. All right. So all done, that's what we're looking for in part A. Like I said, you should be getting that too. If you're not, then send me an email or see if you can figure out where you're going awry on your own. Okay, on to question B here. It tells us that, or it asks us, according to your estimate, what happens to the transit authority's revenue when the fare rises? Okay, remember, revenue is the amount of money they're receiving from customers. Think of it like as their sales, without saying anything yet about costs. Okay, so they've raised their price and they're getting more money because of that, but on the other hand, they're selling fewer tickets because now they're more expensive. So we want to know which of those things is the more significant factor. We can tell based on the elasticity. So here you want to base your answer on the total revenue test. That total revenue test tells you that if you have inelastic demand, then the price change and the total revenue change will go in the same direction, right? So what that means is that when things are inelastic, the price goes down, the total revenue goes down. If the price goes up, the total revenue goes up too. That's always going to be true with inelastic demand. In contrast, if you have elastic demand, right? If this were 1.24, say, with elastic demand, the price change and the total revenue change go in opposite directions, meaning that if price goes down, total revenue would go up. If price goes up, total revenue will go down. So really to figure out what's going to happen with our total revenue, we just need to interpret the elasticity that we just calculated. We can see here that it is 0.24, much less than 1, which is the cutoff for deciding elastic or inelastic. So we most definitely have inelastic demand. That tells us that if the transit authority here raises their prices, they can expect their total revenue to go up as well. All right. Finally then, part C is asking us, why might our estimate of elasticity be unreliable? This is an interesting question for me. The first thing that comes to mind for why you might have some doubts about the elasticity that we've just calculated has to do with the ceteris paribus assumption, right? We have calculated the elasticity here based on what actually happened at this one point in time. However, it's possible that there were other things taking place in the world that were driving the behavior here, right? We don't have a perfect world in which to calculate elasticity, right? So we're seeing here, in other words, that people are buying fewer subway tickets. They're riding the subway less, and we're thinking that's because the price has changed. But we don't know that it's not because of some other change that could have taken place simultaneously, right? In other words, it could be the case that I don't know, people were laid off in New York at the time, and they weren't taking the subway to work or something like that. And that's driving the behavior rather than the price change. Or it could be the case that there were changes with respect to Uber or taxis or something like that. And that's driving the behavior here and not the price change. There's no way to really get around that when looking at real-world data because there's lots of different moving parts to problems like these. But that would be the first thought that I would have in terms of questioning that elasticity calculation that we put forward, is that it's based on observation in this one particular point in time, while we haven't controlled for other different things that were changing during the same period of time. There you go. I hope that helps.